Wi-Fi routers. Okay, good. So hopefully you'll know a lot of this stuff as we're going over tonight. You've heard of it maybe on your setups possibly. One is the first one right off the bat is IEEE, which is the governmental business, governmental kind of quasi-governmental business organization that sets up all the standards for internet security. And they have an 802.11 wireless security protection standard that we've been using for a number of years. And it basically defines the vulnerabilities of an open system communication, web, and device authentication. We now have WPA2, WPA Security as well, both business and personal. With an enterprise version of WPA2, you need your own server for that enterprise version to work. You can't get this at home. You can only get the WPA2 personal on your home wireless router, and your home network will not work without its own server, the enterprise version. So we'll look at how enterprise works though in security. We have enterprise here on campus. So 802.11 again started with the Institute of Electrical and Electronic Engineers. They do have a student branch. I do mention it in my networking class, like the first week. But IEEE.org they do have a student branch. If you're interested while you're a student, you can get discounts to become a member. You get a lot of free stuff. They do have yearly events that are open to students in Chicago that are a lot of fun. It has to all do with networking, programming. An example would be one of the conferences every summer. Students have competitions on how quickly you can set up a secure network, how quickly you can hack a network, how quickly you can hack a wired network, how quickly you can create a network, how quickly you can create a program to crash a web server, how quickly you can hack into a switch. And so they go a whole bunch of different how-tos, and then they unleash the students to do a competition immediately after that you learn whatever it is that they're teaching in the conference. And so it's good practical hands-on things. But IEEE is the most widely influential organization when it comes to networks and wireless. And in the early 80s, they began developing network standards because there was a vacuum in the 80s when things started really going gangbusters in the corporate world with computers and connected to the internet. The government and even business noticed that there wasn't any standards at that point, and so there needed to be some type of standards to set up protocols to where things would be secure and communication would be secure. So it started out in the 80s. The work project initially was called 802. The document was called 802. And anytime you're wanting to find any papers on anything related to network security, if you type in whatever you're looking for in Google and then just type a space and then white paper, you'll generally get an article from these guys because they have tons of articles, thousands of articles, and they call them white papers that are just long documents explaining the technology and the rules and regulations. In 1990, they formed a committee to develop standards for WLANs, wireless LANs, that operated on a whopping 1 and 2 million bits per second. Most of you guys are used to 54 megabits per second. Now currently up to maybe 124 on N megabits per second. And so back then it was just a 1 and 2. That's it. But it's better than what they had prior, which was 0. And so at least they were having data for the first time, transferring data wirelessly. It's kind of like, the first time we talked on a telephone, or the first time we sent data from California to New York University over a LAN. And so it was a pretty big thing. But if you think about it, 1990, we're 2013. It wasn't that long ago. And the reason I mention that is everything I read and every conference I go to and everything that's coming out in wireless, we're still in the infancy stage when it comes to wireless. It's a fairly new technology. And it's growing by leaps and bounds. each year on how companies use it, how devices use it, but it's still very new when it comes to technology. So it operated in, like I said, 1 to 2 million bits per second originally in the 1990 area. And then in 97, they approved what you guys now have at home, all the way up to N anyway, the standards for 802.11. It started out with A, then B, then G, then N, which we currently have on the shelves. And so these are the standards, and again, that just started in 1997. Okay, less than 14 years ago is when that started. And so again, fairly new to technology, fairly new to controlling it. So one of the first things out of the box you think of as a security analyst or security person is how to control people getting into this device, right? So one of the ways they first decided to do it was by restricting the access to the access point. Was basically you could do a couple things. One was MAC address filtering initially. That's all they had. And so you could basically just say, okay, only these devices that these MAC addresses can get in. That was before web security. That was for WPA security. That was the very first type of security. And you can still do this today at home on all your wireless routers. You can block and filter MAC addresses from connecting to your wireless router. And so say you have a list of 2 or 3 at home and you only need 2 or 3. Most of you probably have 50 addresses available at home, and you only use maybe 2 or 3 addresses. And we'll talk about that as well. That could be a security issue. And so even businesses, though, have a lot of addresses out there they don't need. You can make that a little bit better by managing those addresses. So by restricting the access point through MAC address filtering was the first way that came up. That's all we had. And so what I did on this one basically is you've got your access point. Notice here you've got your wireless laptops connecting to it. And those 2 wireless laptops, we could say, are the only 2 laptops that can connect to this access point. That's it. Nobody else can. If you try to connect, not going to work because you don't have the correct MAC address. Make sense? And again, most of you probably have never used MAC address filtering on your routers at home, but it is there and you can use it. And you can turn it on. And all your routers already know every device that's ever been connected to it because it remembers connections. And so you don't have to manually type in those MAC addresses. You just have to click on them, turn on MAC filtering, done. And now you filtered those 2 or 3 or 4 devices that most of you use anyway, and everybody else can't get in. And so now guests will have a problem. You have to, that's why people don't do it. But really, if you think about it, most of us don't have a lot of guests over connecting to our Wi-Fi. Maybe once in a blue moon. And then in those cases, we could, just turn it off for a period, turn off MAC address filtering for a period. But it is one way to manage it. Now, what is an issue you think with businesses on MAC address filtering, or schools, or whatever you think?
Somebody spoofs the MAC address.
Spoof addressing, and then just let's forget, I guess, any security issues. What are some other issues you can think of?
New equipment.
Do I know?
New equipment.
New equipment would be one. And what else? I'm thinking of a big one here. Somebody's got to enter in all this stuff, right, and manage all these numbers, right? Somebody or 2 or 3 or 4 people have to do it. So literally maybe be 1 or 2 or 3, 4 people's jobs just managing MAC address filtering, or part of their job. And so that's the reason why most companies don't do it, is because it's a waste of money in their mind to do it. And there's a few schools that did try it, and it fell really flat on their face trying it, because it was a nightmare. Because all the different devices, they had to bring their laptop or mobile device to the IT department every semester, register it. Then you had students that would spoof the MAC addresses, but that really, to IT, they could care less about that. What they really worried about and didn't like doing was managing the MAC addresses coming in. Not that they didn't care about spoof MAC addresses, but that was the most headache, was managing it, managing the numbers. And so it's really not a real productive way to do it, but you can do it on a small LAN, which everybody in here has a small wireless LAN at home. And it is easy to turn on. It's easy to keep people out with MAC address filtering. Because if you think about it, most of your neighbors, drive-bys, aren't going to be doing MAC spoofing. But they are going to be looking to see if there's an open Wi-Fi access point. A lot of people do that. And if you have one open, it doesn't take much time for you start seeing people connected to it. And so there's a screenshot here of a Linksys router and turning it on, the wireless MAC address filtering, permit only the PCs in the edit MAC filter list. So pretty simple. And when you clicked on this one, you'd actually see another screen that would have all the devices ever connected to your wireless access point. You click on the ones that you want to access and apply it, and that's it. Pretty simple. So MAC address filtering is usually implemented by permitting instead of preventing. So it's whitelisting instead of blacklisting. So you're just adding in the list those users you want in. You could care less about all the users that, try to get in, just the ones that you want in. The other one is WEP. This is the very first. So we have MAC address filtering, then we go to WEP filtering, WEP security. WEP was the very first security when it comes to wireless access points. And it was designed to ensure that only authorized parties viewed that data. It did use encrypted traffic. And the IEEE committee designed WEP to meet the following criteria: be efficient, exportable, optional, self-synchronizing, and reasonably strong. And at that time when it first came out, it was all these things for sure, because it was the only thing we had. WEP does what's called 4 secret keys. You have 4 secret keys available to you in WEP to use. And there are 64-bit or 128-bit or passphrase option for WEP. And the access point can hold up to 4 secret keys, and one of which must be designated as a default key. And some of you have used WEP. You've already seen the four options I'm talking about. Most people just leave it at the top radio button, fill that in, and they don't even do anything with the other 3. They just keep the top one open, and that's it, and that's the one they use. And so basically you have here, you'll notice the access point here has these 4 keys available, and the default is this one. And you'll notice when these laptops connect to the access point, this one here grabs key 2, this one here grabs key 4. When they actually access it, they enter in those values, and they get in to the access point. Basically, is what they're doing. So you have 4 options to get in, 4 separate access points, 4 separate access passwords, you could say. And it worked. It worked fine. It has a deciphering mechanism, where basically you have the text that you type in the actual option 1, 2, 3, and 4. It goes through an algorithm. Then it goes through a programming secret key algorithm on step 2 to finally give you a key stream, which kicks out a XOR command, which is a leftover value of a decimal or of a divisional statement, XOR, and then it finally kicks it out to a ciphertext. Okay, the problem with it is over time, hackers realize that those 4 keys could all be different for sure, all right, but the ciphertext algorithm is the same in WEP, and so they could do a randomization of values to be able to determine the key. And so it would take, in some cases, depending on how hard the keys were they entered in for the options 1, 2, 3, and 4, it could take seconds to minutes, at the most 30 minutes to an hour to hack WEP security type of keys. And so here basically this screenshot just showing you a sending device going through the transmission ciphertext and then the receiving device. The 2 things I want to mention in here, the only one thing I want to mention in this is the secret key. The shared secret key has to be the same on both ends in order, if somebody got the traffic in the middle, like a man-in-the-middle attack, without the secret key, they wouldn't be able to unlock it to see the data. All right? And one of the ways we'll talk about in WEP is hackers figured out quickly how to, again, find out the secret keys because they're only up to so many characters long. And anytime you give anyone knowledge of how long your passwords can be or have to be, and also the structure of those passwords, the easier it is to hack. And that's why I really don't like banks publicizing my security protocols to the public. Like when you enter in a password, it'll say, okay, make sure, and this could be a non-customer, could say on a lot of bank accounts, websites, you could say, make sure your passwords, if you put it in, you could just put in a bogus username password. Immediately it'll pop up a help message that says, did you make sure and type in your password? Remember, it's got to be a caps letter first, this many characters. You have to have maybe a special character and a couple numbers on the end. Well, I don't want anybody to know that. Why do they need to know that? If they're not a customer, they don't need to know it. And if they are a customer and they forgot it, they can call the bank. And so by doing that, we think it's kind of for non-security people, when they see that, they think, oh yeah, my bank's secure. Look at that. Look at that. Well, they're just basically feeding the hacker community with folks that would want to hack it with a shorter pool of numbers and characters to deal with, because they know exactly what field to work with, what field of numbers to work with, and range of numbers to work with. And so anyway, controlling access with WEP had its limits, and one of the things with that is, I already mentioned, and it's not in the book here, but is the cracking of WEP keys. Now there is some tools in week 6 I have in there already, and some documents in there that you're more than welcome to look into. We're not going to get into it this week, but on WEP cracking and air sniffing and air cracking, there's a whole technology on specifically targeting WEP security. And the reasons a lot of networks still have WEP security is because they still have a lot of older devices on that network. You have to have whatever your weakest device is the security you're going to have on your network. Does that make sense? And so if companies have laptops that are, say, 4 or 5 years old, they might only be able to talk well to a WEP access point. And then granted, they might have 80% of their laptops, the newest and greatest, but they have to set up their access point to be WEP so everybody can talk to it. Now you can make that WEP key very long and ugly for sure to make it more secure, and you definitely should. But it's still not as secure as WPA is today. And but it's better than nothing, that's for sure. And so a lot of students in this class that have older laptops in the past, especially when N came out initially, a few years back, and they were working on B and G at that point, it wouldn't work with N. Some of their devices wouldn't work with N, so they had to roll back to WEP and to get it to work. And so you might have to do that at home as well. You might have older gaming systems maybe that use wireless, which I don't recommend. If you're going to have a gaming system, you probably need to hardwire it into your router. But there are some students that is fine with wireless, like a Wii or something. Maybe just do some limited wireless stuff. In that case, if it's an older device like that, an older Wii maybe, it might only use WEP well, and that's it, not these other newer technologies. So that's one of the things, you can't always have the best in business. It depends upon the clients that you're working with, the laptops or desktops, mobile devices. Now, one of the limitations also with LANs is walls. Now, it says here wireless LANs cannot limit access to wireless signals by walls or doors. You can't, but you can power down or limit the power of that signal. There is an MTU setting on a wireless router that I don't recommend playing with, just to play with it. But anyway, what it does is it basically weakens the signal power of that access point. Most commercial ones that you buy at home, I wouldn't mess with those. But like the Cisco ones for commercial businesses are very powerful. and you can say, okay, I only want this to range from here to the edge of the building, and you can play with that number to literally get it to that level, and it'll stop where you want it to stop. And so most of the home routers are a little limited in that, but it is called, most of your home routers will have an MTU setting, but if you play, it's usually set at like a number 5, I believe, on most of your home routers. And I believe it goes up to 10 and all the way down to 1. And that's the power of that signal beacon. And so you can, the book says you can't limit it, but you can by using an MTU. Now, types of authentication supported by 802.11 is open and shared key. We've already went over shared key a little bit as far as web goes. Open, meaning I have an access point, I just open it up to anybody to connect, a guest account, which a lot of businesses do and hotspots do, and that's fine. So here's an example of an open system. And the access point here, basically the 2 laptops here just connect through the SSID bill. That's it. That's all they connect through. You just click on the SSID on the access point or on the devices, and you're in. There's no password to authenticate. You're just basically authenticating through an SSID, and that's it. It's open. And it works well, I guess. You know, it does work well with guest accounts, guest wireless accounts. And in that case, I always tell students, we're talking about guest accounts and access points, to always use a DMZ port on your wireless router, which you have. And you can set that DMZ port to only maybe search the web, and that's it. That's all that wireless router is going to do. To search a web, it's not going to have any access to anything else in your company. You'll be able to search port 80 and go to Google and anything else you want to go to, but they're not going to be good. It's going to be totally separate from your network files, if that makes sense. And so you can set that on DMZ port to do that through a guest account. So here what's happened on authentication, simply the laptop wants and sends a frame to the access point. The access point fires back some type of authentication key, a challenge text. Then it has an encrypted text that it brings in here. That encrypted challenge text shares a key, shares with the access point that shared key, and returns it back to the access point. Then finally, the access point encrypts a text of its own, sends back to the laptop. You're now in. All right, so it's a challenge key, public and private key, and lets them in that way with an authentication encrypted key. So down here at the bottom where it says AP encrypted text and laptop encrypted text, you'll notice both of these texts are equal at the end once they're decrypted. So they are encrypted. Even in WEP it had encryption, but not real high encryption. So the primary vulnerabilities you can probably guess with systems that are open are letting everybody in. We've already talked about WEP, what the vulnerabilities are there. MAC address filtering, we talked about the vulnerabilities there, which is basically management of the said systems. And only thing I'm going to mention on this slide is beaconing frame. You do have the ability in your access point to turn off beaconing frames to where it doesn't beacon. People don't see the SSID. The problem with that is there's some older devices, even newer devices, that have an issue with beaconing being turned off. Even though you manually type in the SSID on a laptop on a non-beacon system, I've seen laptops, even mobile devices, drop that activity, that wireless activity, a lot in those cases because the device itself is looking for a beacon to keep it alive. If they don't see a beacon, it dies. It just kills that connection. You have to continually connect to it, connect to it, connect to it. So some older devices and even newer devices have issues with the beaconing being turned off. So once a wireless device receives a beacon, it can attempt to join it. And most of your laptops are actually set up to search for beaconing devices about every 2 or 3 milliseconds. And if it sees a new one come in, it can connect to it automatically if you set it up to be that way. Or if you've connected to it in the past, it'll connect to it. And you don't have to click on it each time. Like at home, I'm guessing. That's the way it's set up. You walk in, you fire up your laptop, it connects. You don't have to click on it every time to connect to it. But there is what's called passive scanning. And this is basically where a wireless device simply listens for a beaconing frame for a period of time, like Windows does this, and even Macs do this. And then after a period of time, it stops looking, then it kicks it again, and then when it kicks up again, it recognizes the new SSID, and then it pops up a little bubble in your Windows machine on the lower left corner and says, hey, I noticed a new SSID, do you want to connect? All right? That's the purpose of passive scanning and what it does. And so for a degree of protection, some wireless security sources encourage users to configure access points to prevent the beacon frame from including the SSID. The problem with that is any of the scanners we talked about tonight at first of class can recognize all of that. Even though you hide them from the beaconing, they can find them. Okay? If somebody wants to find it, they're going to find it. So a long way to secure it is not through that way, but through the actual how you set up your... If there's going to be web, make sure it's a really hairy password. That's a long, ugly password. Alphanumeric password. And you can set up a nice long one, you know, and that people won't be able to guess. And it has nothing to do with your business, nothing to do with your home. Here's some problems that arise with beaconing being turned off and the SSID being turned off through beaconing. It can affect roaming. I've already mentioned that. It can also affect machines running Windows XP, which some people still have. And then also the SSID can be easily discovered through apps I've already mentioned, like NetStumbler, Kismet, AirRadar. It's virtually no protection turning off your SSID from being beaconed. So here we have a LAN, WLAN with multiple access points. We'll say here for an example that this one over here, we'll say it's a guest one, because notice it's not connected initially to a file server. We'll say basically that this access point, it may be pointed to a DMZ computer over here, and all it has on it is information about the company, web server, documents, and that's it. So if they were to get into anything in your computer network, it would be that server through the DMZ port. Because when you set up an access point, you already know this probably, if you're setting up a home, you have to plug it into your modem if you have it at home. If it's at work, you're plugging it in from a wall somewhere that has internet connection. Plugging it into the internet port on the access point. Well, you have to make sure wherever it's plugged into that wall, from that wall, it goes directly to a server somewhere. You want to make sure that's on a DMZ port. The DMZ port will be the area that doesn't really matter if anybody gets in there. It's just going to have maybe documents, maybe a web server. That's it for your company. MAC address filtering weakness. I'm not going to talk about that. I already did. WEP filtering weakness. I do want to mention the second bullet. Talking about WEP filtering or WEP. It says violates a cardinal rule of cryptography. Anything that creates a detectable pattern, which it does, I mentioned already, it's a detectable pattern that hackers figured out quickly, that this WEP key that travels across the internet or the wireless waves has what's called IVs that repeat every few hours the same IVs over and over again. Doesn't take but in a few hours they start repeating. And so they just set a scanner up in a WEP environment, find out what those are, and that's how they initially did it. Now there's actually applications that have pretty much all these vector IVs in an app, and it just scans for all of them at once, and then within seconds you can literally crack a WEP password of any type on a WEP secured device. The only benefit would be, or only secure thing would be, is if you had a really hairy password. That would definitely make it go longer. And they might give up. So they had what's called a keystream attack that came upon WEP activity that basically attacked the IV stream, interjected it, found it, deciphered it, and then entered in that password, get admin access to the access point, and change the admin password to something else. Now they have total control over that access point. And then go configure it to something different. Maybe throw in it a incorrect update to the firmware, which will fry the access point. If you update a wrong firmware to any hardware device, laptop, desktop, wireless access point, it'll generally fry the firmware, the hardware that uses the firmware. And so a lot of times that's what they originally did to hack them, is that when they got into them, they would basically take over them. And you guys know this, on your wireless routers, there's an area administration where you can look for updates. That's the area I'm talking about, where you can browse out for a file and look for it. Now they make it to where you guys don't browse out for a file. I believe they just browse your web. It browses a web service for the manufacturer. And that kind of helps on hacking those now. But used to, you could literally browse a local file, upload it, and they'd upload a wrong firmware on purpose that would crash the access point. But no longer that's the case. You can't upload a firmware anymore. I believe on most of your routers, it does it from the web. On web encryption, the only thing I want to mention, because we're going to talk more about encryption, we'll get to the email lab here coming up here in a week or two, I believe. Get more on encryption, ciphering keys. But the one thing I do want to mention on this one is it has a couple of operations that's happening. The main operation, two operations, is the text is entered in, okay, which is converted to a binary number. Then the key stream, which is also binary, is then converted to a ciphertext. So this is the ciphertext is actually brought in, and the final operation over here at the operation 4 has a final binary number, but the part that was grabbed onto was the calculation, the ciphertext calculation, is XOR. Every few hours it would be repeated with the same IVs going across the Wi-Fi, and once you figure out the key, and that's what these XORs are basically here that it's showing, it could decipher that ciphertext and find out the password easily to get in. One of the 4, and generally find out the default one that was set. So here's a packet 1. Notice 1, 2, 3, 4, 5. Packet 222, 1, 2, 3, 4, 5. Over a period of time, these packet ciphers repeat over and over again, and then they can just determine from that the actual password from the ciphertext by just trying it over and over again, these packets. So after WEP came WPA and WPA2. Most of you guys use this at home, I'm guessing, the WPA, WPA2. And it is, again, from a Wi-Fi alliance and IEEE that came up with these securities. Personal security is what they're calling it. Personal wireless security. And the WPA Personal Security is a wireless Ethernet compatibility alliance that is a consortium of wireless manufacturers and software providers provide goals. The goals are to encourage wireless manufacturers to use technologies, IEEE technologies, promote, market these technologies, and to test them. So they've done a pretty good job over the last 3 years, this group, in getting Wi-Fi in a lot of places. And a lot of countries, they even work with a lot of countries to do this in areas that don't have any access at all, getting them in all different areas, locations, and environments. And then in 2002, the WECA organization changed its name to Wi-Fi Alliance. You actually see that on your devices now, the Wi-Fi Alliance. In October 2003, they introduced the Wi-Fi Protected Access, which is WPA. And basically, its design was for present time then, at 2003, to future, which we're still in the WPA arena. We're now in WPA2 Personal Enterprise currently. It started originally out with that bottom PSK and TKIP addressing, which was basically had to do with encryption. And the first time this came out, I remember setting it up on WPA2 using TKIP and using PSK. It took about person knew what they were doing. We had about a 15-page document on how to set up your access, how to set up your initial connection on a laptop. It was 15 minutes roughly to set it up on each laptop. And that's when you knew what you were doing. You created the steps and you knew what you were doing. People that were just given the document were telling me it would take them up to an hour or 15 minutes. So after about the first week we had it here on campus, it was only about 2 or 3 of us, I think, that actually were using it. Everybody else said, forget it. I'm going on at that point it was, the student access point that everybody was using. So he just went over to that. So, but now it's a lot easier. With WPA2, you still have TKIP and PSK in it, but you don't have to manually, because what you'd have to do is go through all these different screens. Click here, click there, don't click that. Click this option button, click that option button. Type this in, type that in. Oh, go over here, save that, update that, download this. Okay, install that, go over here, configure. And after about 5 steps, it'd be like, forget it, I'm not doing it. Because I remember asking some faculty, I said, so what do you think about that WPA? It's pretty secure, right? They're like, yeah, it's so secure, I'm not getting in. But it changed after about 6 months. It got better, which it does in all technologies. But PSK is definitely just authentication of a password to generate an encryption key. And it does it on the fly each time it's connected and every time that access point's connected to that device. And it's for encryption. And it has what's called an encryption seed that mathematically is generated for each one of the encryption keys as it goes across the wires or across the Wi-Fi stream, and it's encrypted each time differently with a different seed. Unlike WEP, remember, is repeated every so often. In WPA, they're never repeated. Those are never, the same numbers are never repeated. When I say never, it might be repeated maybe once a month, once to 2 months or something like that. So WPA replaced WEP, which is a huge step in encryption and in security. And they added a new encryption technology I already talked about called TKIP. It used several advantages over WEP, which had a longer encryption key of 128-bit. It had what's called packets per packet keys that would be changed on the fly each time it went across wireless. And then when coupled with other technologies, even greater security. And WPA also replaced the CRC function in WEP for message integrity. Then came the Wi-Fi protected access in 2004. Still uses PSK, but instead of TKIP, it uses what's called enhanced data encryption. It's basically the brother of TKIP. It's still TKIP, but you don't have to configure it anymore. It's just built in to the PSK technology. So now what you do is when you click on an SSID that has WPA2 personal or enterprise, when it's set up, you enter in your username and password for that environment in an enterprise area. That username and password is your network username and password. You enter it in one time, and then it lives for 24 hours on that machine. So if you go in throughout the day, come back tomorrow morning, you're not going to have to click on that each time to connect to it. Now, after that 24-hour period's done, then you would have to click on it, but you wouldn't have to enter in your username and password. It would remember that. But you would literally have to click on like I had to do tonight whenever it turned off. I had to click on it a couple times to get connected. That's it. And so it still does remember you, but the security part is it dies after 24 hours. That connection dies after 24 hours. There is some weaknesses in the PS key management, is that the PSK only uses a single key, and changing the PSK key requires reconfiguring that key on every single wireless device and every single access point. So in order to allow a guest user to have access to PSK WLAN, the key must be given to the guest. And so because it's given to the guest, that is a weakness with that. Now WPA2 Enterprise, though I don't believe it's in the slides here, has gotten rid of that now, where the PSK is actually built in to the authentication. And even a guest user, you would just give them a guest username password. They'd enter it in. It would be live for, say, an hour. And then that's it. It'd be live in the system for an hour, and then it would die, and that transmission would be over. As far as encryption types, when it comes to WPA, WPA2 security, they have what's called AES and CCMP encryption, which is basically a higher encryption of close to 256-bit encryption, very highly secure, and the algorithm that's used for this is a really advanced algorithm that dynamically is reset every time a packet is sent across the airwaves. So if it was captured, it'd be very difficult to near impossible to crack with the WPA2 security using the CCM algorithm. So, wrap it up here. WPA2 security. We're actually here, home users, you guys are using, I'm guessing, this bottom one now. It's one of the newer ones. It's WPA2 Personal Security Encryption, AES CCMP. Look at the security level on that. It's high security level. And we're finally at a level of security now to where military, who's been helping on getting everything up to par and doing all the testing, probably within the next 3 to 4 years, we'll be using wireless in the field. Up to this point, they've not been using wireless in the field because of its lack of security being intercepted. And so, but it's getting there. And I had a student last semester that's what they did prior to being a civilian again. Was one of their jobs was they were an encryption algorithm analyst for the military, and they did their presentation on it that semester, which was way over my head, on encryption. They were specialists in it, had a master's degree in algorithm and encryption, and we're going on to the doctorate, I believe. But anyway, this guy did field studies in encryption, and he couldn't give us all the information because it's still private information, governmental information. But he did say it's amazing some of the things that are going to be. He was able to say the stuff they're doing will just blow you away. Speed-wise that they're working on, like he did say, some of the speeds they're dealing with is like 10 times the speeds that we have with N at home now. And he said security-wise, some of the security they're dealing with now with wireless actually supersedes wired security, which was totally unheard of 2 or 3 years ago. So, and it's made where it's easily configured on the client side. And so they're using things like satellites for security for governmental, whereas before they were relying upon private ISPs, governmental. Now they're talking and using and testing via satellite. So getting the internet connection and their transmission connection through satellite feeds that we own, those satellites that we own, which are much more secure but much more expensive too, because each satellite costs like $1.5 million to put up a little satellite. Which I don't know if you knew this though, but a lot of businesses now are buying their own satellites, and you can pay 10, 20, 30, 40, 50, $60,000 and get a small satellite. You can hook up together with other businesses and get it launched into space, and it's dedicated to your business. And a lot of folks are doing that. A lot of businesses are doing that. But the government's been doing that for a number of years and testing wireless, because that's the next thing that's going to be coming, according to this student, was having access. You guys have already heard probably of like Dish and some others that have access. You can get internet downloaded. This is totally different. What this is talking about is having devices that wirelessly talk to satellites. That you get their connection through a satellite feed, kind of like your GPS. Your GPS gets its connection through satellite feed and coordinates. Same technology, but applying it to wireless or applying it to networking. So that's what they're playing with. He did tell us that. So I thought that was pretty exciting to see that and to hear that. But what we see now is, like, again, 1997 was when the very first device hit the markets for 802.11b, 1997, and we're in 2013. So we're still in the infancy stage when it comes to wireless, and we're going to keep going up and up and up. And as far as the field of wireless, if you're talking about going into a field in networking, it's definitely ripe right now, big time. Healthcare, medical is huge in wireless. And not only that, but all of the technologies that are coming out within on wireless security and WPA2 enterprise are getting better and better when it comes to security. So if you notice, your doctor's offices, your hospitals now, a lot of them are being converted, in clinics being converted to totally wireless. From, you walk into the doctor's office and he's got a wireless iPad or wireless laptop or whatever that he's using. Nurses are using it. Even in ER they use it, and so it's being infiltrated. If there's one place to get your foot in the door when it comes to networking with security, definitely healthcare is big. And the benefit of healthcare is it's not going anywhere. It's unlike any other business. People are always going to be sick. That's terrible to say, but it's the truth. And so, as far as healthcare in itself, as far as the field for network security, it's wide open right now. And I know here in Rockford, they're converting all the clinics first to wireless, and then they're going to do the hospital last. The mothership they'll do last, which is going to be the hardest one. But there are jobs like that right now. There's tech jobs open in every single hospital in this region for networking students, for sure. It might be like a third shift data analyst or whatever, but they are opening them up. They are opening up, and jobs are available in those areas. So if you're interested, it's definitely something to get your foot in the door with networking. So that's Wi-Fi security on Thursday. You're going to do your take-home, and there's no face-to-face class. Any questions on the take-home? Okay, we're done. Good job. You have any questions, come up and see me. And be careful out there walking outside.